Hello and welcome back to Miss Mackenzie's classroom by distance. All right, today we are going to do the last unit in last lesson, in this unit where we write a quadratic model function. So I just want you to recall some good old math 10 stuff. Okay, you learned that y equals mx plus b for a linear function, and where m is the slope and b is the y-intercept. And we called this format the slope-intercept form, but we also called it an equation. And then your teacher threw this at you, where f of x equals mx plus b. All right, this is called function notation. So if you were asked to do the function of something like 3, you would put a 3 in for x and you would solve. But basically, it's just a different way of looking at the same thing. This function notation just took the place of y, all right? And it's not actually a part of the equation. You're not multiplying an f with an x. It's function notation. So if you were given f of 3 like I've written down there, you would substitute 3 in for x, and then you would find out what the whole thing on the right side equals if x is 3. If you were given something like this, where f of x equals 3, that's a different thing. That means this whole thing is replaced with 3. It's the same thing as saying y equals 3, and then you would solve for what x would have to equal in order for the whole function to equal 3. So we're going to kind of continue with that a little bit right now. Right? So this is where you have to use function notation or the concept of vertex form to figure out the answers for a problem. So obviously, this isn't a real life, real world problem that we're solving for example 1, but it's just to help you understand what we're doing here so that you can eventually use this for more complex things. This is find algebraically two numbers whose difference is 10 and whose product is a minimum. So if we let x equal number 1 and we let b equal number 2, we can start putting things together. So we know that x minus b equals 10 because it said that they have two numbers that have a difference of 10. And then they said whose product is a minimum. Whenever you see product and minimum maximum, you're going to want to start thinking parabola, because remember, we have parabolas that look like this, where you have a max value, and things that look like this, which have a minimum value. Although we're doing a very abstract problem at the moment, finding minimums and maximums is something that a lot of companies do every day. They do it for production costs. So they want to know what the maximum production costs can be, or they want to know what the minimum they can spend on something. So it's used a lot in cost benefit analysis. Right now, we're just going to use these this more simplified version or problem. All right, so this is step 1, is we defined what our numbers were. Step 2, we figured out one of the relations. And step 3 is where that function notation is. So you could use like y, or you could just say that the product is a function of whatever x is. So if you were to do a product of these two, that would be taking x and multiplying it by b, right? I forgot that I was also going to solve, and I actually just want to keep it as a product of x. I want to keep x just because that's the way I did my notes. So I'm just going to move this down here, and I'm going to solve the earlier question for b. Now I could have done it below what I wrote for step 3, but I'm going to do it up here. We're going to add b to both sides. No, we're not. We're wanting it to be what b equals, so we're going to subtract x from both sides. That's going to give us negative b equals negative x plus 10, and then we're going to divide everything by negative 1, and we're going to get that b equals x minus 10. Okay. So now, going back to step 3, we're going to substitute all of this in for where we see b. And the reason why I did b was because I'd already written that this was a function of x over here with my function notation, and I kind of wanted to stick with that. So I'm going to rewrite my function of x that equals x times x minus 10. Now I want to expand and simplify. So I am going to do x times x, which is x squared minus 10x. Okay. So we've learned that the maximum and minimum occurs at the axis of symmetry, and the special point on the parabola that lands exactly on the axis of symmetry is the vertex. So here's where it is very beneficial to flex our completing the square skills and complete the square so we can put this into vertex form and figure out where the vertex is. So we're going to rewrite this as x squared minus 10x, and then we're going to complete the square. So half of negative 10 is negative 5. Negative 5 squared is positive 25. We can't willy-nilly just add 25 to this function. We can only add things in zeros and multiply things in ones. So I'm going to subtract 25 too. So then I'm going to rewrite this as x minus 5 squared. So the first 3 terms became that part, and it's minus 25. Okay. So this is a function of x, f of x equals x minus 5, negative 25. And this tells me that the vertex occurs when, remember this is our p-value and this is our q-value. So our vertex is at the point 5, negative 25. This is the minimum product that can be made, and this is the value of x at that minimum. So we have found that x is going to equal 5. That's one of the numbers. The only other number we need to find is what b is. Remember, we had x, ooh, no, that's not what I want to do. We had x is number 1. We now need to find what number 2 is. And conveniently, we already have an equation that helps us find that really fast. So that's going to be our step 5 or 4, just to find what b equals. We know b equals x minus 10. We now know that x is 5. 5 minus 10 is negative 5. So our solution is x will be 5 and b will be negative 5. And that is the best combination of 2 numbers that have a difference of 10 and whose product is a minimum. Now there's lots of numbers that have a difference of 10. You could take any number and get a difference of 10, but will they have a minimum product? And that is the little catch there. So let's try another question. Wayne, the ostrich farmer, wants to build a rectangular fenced enclosure divided into 5 rectangular pens. A total length of 120 meters of fencing material is available. Find the overall dimensions of the enclosure that will make the total area a maximum. All right, so first of all, let's be honest. I don't know any rancher who would actually bring out the pre-calc 11 math and calculate this. They would just build the fence, and if they needed more fencing, they would buy more fencing. And if they had more than enough fencing, they would just keep the extra fencing for mending or sell it. Okay, so I acknowledge that this isn't exactly the most practical question, but again, we're using this to kind of understand how it can be used for more complex problems or more realistic ones. So first of all, let's just kind of sketch what this pen looks like. We have this pen. It's a rectangular pen, and it has divided into 5 rectangular pens. So we need to 1, 2, 3, 4, and 5. Let's just pretend those are all the same shape or size. Okay, so if from here to here is the width, that means from here to here is also the width. And from here to here is the length. And we have 1, 2, 3, 4, 5, 6 fence panels that are all the same length. Okay, so our first step is to define our variables. So we let L equal length and W equal width. Okay, now we're going to figure out our equations. So we have to go to where they've given us more information. They said the total length is 120 meters. Okay. So that means if I add up all my L's and all my W's, it should equal 120. So my perimeter will equal, there's 2 widths, there's 2 fence lengths or panels, fence panels that are the same dimensions. We call that the width. And there are 6 panels that have the same length. Right? We also know that the perimeter, I use P for perimeter, but the whole perimeter, all the fencing has the full length of 120. So we know 120 equals 2W plus 6L. All right, so here's where you have to solve for one of them. And I decided to solve for W to get what W equals in terms of L. So here I'm going to subtract 6L from this side, which means I'm going to subtract 6L from this side. So I'm going to get 120 minus 6L equals 2W. And then I'm going to divide everything by 2. And I'm going to also just switch the sides that everything's on. So I'm going to put W on this side. So 2W divided by W, or 2W divided by 2, sorry, is W. 120 divided by 2 is 60. And negative 6L divided by 2 is negative 3L. So there I go, I have my terms, and I could also have written it like like this, it's the same thing, okay? So now I have everything in terms of W, but I still can't solve anything because I still have 2 variables that I don't know. So I need a second piece of information that I can use to eliminate one of the variables so that I can just solve for that one variable. So that's going to be my step 3. Okay. So it said that my area is going to be a maximum. So my area is going to be just one length times my width will tell me the total area of that enclosure. So it's going to be my length times my width. All right, and we know that my width, our width, we're in this together, is negative 3L plus 60. So that means where I see W, I can replace that with negative 3L plus 60. So I'm going to go I'm going to go A equals L times negative 3L plus 60, okay? And now I'm going to expand using distributive laws, so times my first term with my first term, negative 3L squared, and then I'm going to do my first term with the second term, which is going to give me plus 60L. So I could have written this as F of L instead of area, but I didn't. I just wrote it in an equation form instead of function notation, same thing. So you're going to get the same answer. Actually, I did write it as a function of L over here. So I can rewrite that, A, and replace it with a function of L equals negative 3L squared plus 60L. And now we need to complete the square because we need to know the vertex. First of all, I want you to notice that the number in the A position for this general form is negative, which means that it's going to open down. It's going to be a parabola that looks like this, which means it's going to have a maximum point. How convenient. All right, so we're going to complete the square, but the first thing we have to do is get rid of that -3 in front of the L squared. So we're going to divide everything by -3. And we're just going to put it off to the right there, sorry, to the left. Just have it hang out weirdly written too, and just leave it there. We're just going to leave it over there because we're going to bring it back. Okay, so -3L squared divided by -3 is going to be positive L squared, and 60L divided by -3 is going to be -20L. Okay, from here we need to add a number that's going to give us a perfect trinomial square with those first 3 terms. So half of 20 is 10. 10 squared is positive 100. We can't just willy-nilly add positive 100, so we have to also subtract 100. We are then going to take these first 3 terms and rewrite them as a square. So again, we're just going to have this -3 hang out here, and it's going to be L minus either half of -20, which is -10, or the square root of 100, which could be either positive or -10, but we know it's negative because it's negative here. So it's going to be -10 squared, and then there's going to be this -100. Okay. We're not done. We have that little awkward -3, which I forgot to write the negative down for over here, just hanging out there. So we're going to multiply everything by -3. That's not to the power of -3, that's times -3. I don't know how to write that clearer at the moment. So that means we're going to have f of L equals -3 L minus 10 squared plus 300. So I want you to notice a few things. One, the number in the A position is still -3, so it's still a parabola that opens down, which means it still has a maximum point. I want you to notice that the number in the P position is 10, and the number in the Q position is 300. This means that the vertex occurs at positive 10, remember you change the sign of what you see in the brackets, and positive 300. So this is the value of, in this case, L, because we had our L taking the place of where X is. So this is the value of X that will lead to this maximum. Okay. So we have solved half the problem. We know that L has to equal 10. Now we need to figure out what the width will have to equal. And conveniently, look at there, I'm already at the same spot. Conveniently, we've already made an equation that tells us how to calculate what W is. So that is our last step. That's step 4, I guess you could say. We have that W equals -3L plus 60. We now know that L has to equal 10 in order for it to be a maximum area. Okay. So now we can figure out what W is by substituting 10 in for L. -3 times 10 is -30 plus 60. -30 plus 60 is positive 30. So here we have our W. We've already figured out our L. So the solution to this problem is that our width has to equal 30 and our length has to equal 10. So the dimensions would be 10 by 30 or 30 by 10, however you want to say it. And there's our solution. Okay. This last one is something that companies do a lot to figure out how to maximize their profit or minimize their costs. So example, I don't know how he went from example 2 to example 6. This is example 3. An amusement park charges $8 admission and averages 2,000 visitors per day. A survey shows that for each dollar increase in the admission cost, 100 fewer people will visit the park. Write the equation to express revenue as a function of X dollars in terms of price increase of X dollars, and determine the admission price that gives the maximum value, because when you're a company, you want to maximize revenue, minimize cost. So we're going, it already tells us this, but we're going to let X equal the number of price increases. Okay. We know that the price of tickets, P in this case is going to be price, is $8 plus 1 times X, because it's a $1 increase. So there's technically an invisible 1 there for the amount of money being added to it, but of course, lazy mathematicians. And we know the quantity of tickets sold is 2,000 minus 100 for every price increase. Remember, X stands for the number of price increase. So for every 100, for every dollar price increase, you lose $100 people paying admission because it's too pricey for them. Okay. So if we did revenue as a product or as a function of X, how you figure out what revenue is you take the price of your admission and you multiply it by the quantity of people, the number of people paying. Okay. That's how you figure out. You take the number of things you sell and you multiply it by the money you get for each item you sell, and that tells you in total your total revenue. So we're going to replace those P's and Q's with these equations that we've already determined. So R of X will equal P. P equals 8 plus X. I'm going to drop the units and the invisible ones. So P is 8 plus X. Okay. So this is the same thing as our price up here. And our quantity is 2,000 minus 100X. Oops, I'm missing a 0 there. So that is our Q. Okay, I'm just gonna finish my color coding here. All right. So now that we've substituted these equations in for P and Q, we now have a binomial multiplying by a binomial, which means we can expand and we can simplify. Okay, so we're going to do 8 times 2,000. Which is 16,000. We're going to multiply 8 with negative 100x, which is negative 800x. We're going to take x and multiply it by 2,000, which is positive 2,000x. And we're going to take x and we're going to multiply it by negative 100, which is negative 100x squared. I'm now going to rearrange and group like terms. So this negative 100x is going to be written first, because we always go in descending degrees if possible. All right. These two here are like terms, so I'm going to group them together. Negative 800x plus 2,000x's is going to give me a positive 1,200x in total. And then last but not least, this is going to be plus 16,000. Okay. So there we go. We have our statement, and currently our statement is in what we call general form. Now there's actually multiple ways of solving this. We are going to practice solving it by completing the square and finding the vertex, because when we complete the square, we get this quadratic in vertex form, which we can easily read off the P and Q value, which is different than the product and quantity value. All right, but it is important to acknowledge that there is other ways to solve this. You could slap that into a graphing calculator and find the vertex. You can use what's called the quadratic formula. There is other things to do, but the quadratic formula actually just gives you the x-intercepts, which isn't what we're looking for here. We're looking for the vertex. So barring technology, the best way to solve this is with completing the square. And the first thing you need to do is recognize that this is not a positive one. So we need to use that wonderful manipulative skill of just dividing everything by that a value to get it out of the way. So it's going to become r of x over negative 100. You're not going to worry about that. It looks really weird, but you're just moving it over there out of the way so you can do your thing. Okay. So negative 100x squared divided by negative 100 is positive x squared. Positive 1200 divided by negative 100 is negative 12x. And 16,000 divided by negative 100 is negative 160. Okay. So now I need to complete the square. So we're just going to have r of x, which is function notation, not r times x, over that negative 100, just kind of sit out there for a wee bit. X squared minus 12x. And now we're going to do some master manipulation. We're going to complete that square. Half of negative 12 is negative 6. Negative 6 squared is positive 36. Can't just add 36 though, I also have to subtract 36. So the grand total of what I'm adding is actually 0. And I can't forget that there was a minus 160 there. I'm now going to write that in the square as a square instead, right? Not forgetting that I have this negative 100 kind of hanging out over there. So it's going to be x. It's going to be a negative because this is negative, okay? And then the square root of 36 is 6, or you could do half of negative 12, which is also negative 6. It should be the same thing, right? And then next what I have to do is group these like terms. Negative 36 minus 160 is negative 196. So that is our completing the square. We're not fully done though, because we can't forget this negative 100 patiently waiting. So we're going to multiply everything by, not 100, by negative 100. And so you're going to get r of x equals negative 100 x minus 6 squared minus 196, add those two zeros, okay? So this tells you the value of x, right, for your vertex. So the vertex happens at 6, and this is, oh, this should be a positive, sorry, because you're multiplying by negative 100. Negative 196 times negative 100 is positive. And this tells you the maximum that happens at 19,600. Okay, so these are our points of our vertex. What this means is this is the value of x when this is at a maximum. And you know it's a maximum, not a minimum, because the number in the A position is negative, which means the parabola that is created opens down, which means it has a maximum point. It doesn't go above that point. So we now know that x equals 6. Okay, it asks us what is the price. So x equals 6. This is the number of price increases. If the original price was 8, the final price would be 8 plus $1 for every price increase. That means the actual price that you're going to be charging is going to be 8 plus 6, which is $14. And that will allow you to have the maximum profit, because although you're losing people coming in, you're charging more, you're making more money for every person that comes in. All right, and if you wanted to find out what that quantity, that amount of people would be in, you could substitute 6 in for x here. 2,000 minus 600 means that you would have 1,400 people coming in, but that wasn't what the question was asking for. Okay. What I'd like you to do now is try these questions here. 17, 18, 19, and 24 are extension questions for if you've really grasped this concept. All right, please let me know if you have any questions. And thanks again for joining me in Miss Mackenzie's digital classroom.